Hello everyone. In today's video we're going to cover three different laws of exponents. We're going to cover the product of powers, we're going to cover the power of a power, and we're going to cover the quotient of powers rule, and we'll do a few examples of each. Okay, the product of powers rule is when we are multiplying like bases, and the rule is when multiplying like bases, keep the base and add the exponents. When multiplying like bases, we are going to keep the base and add the exponents. Let me give you an example of how this rule would work. Let's look at example 1. In example 1, we have x cubed, x to the third power, times x to the fifth power. Now we know that x to the third power means multiply x times x times x. We know that x to the fifth power means multiply x times x times x times x times x. So how many times total are we multiplying x's? We're multiplying them a total of 8 times. So x cubed times x to the fifth will give us x to the eighth. Notice that instead of writing this all out in expanded form, we can shorten our work by just adding the two exponents together. 3 plus 5 gives us 8. Okay, let's look at another example. Okay, first of all, we need to put a coefficient on our first expression, and that would just be a 1. So the rule is that we're going to multiply our coefficients and then we're going to multiply our like bases. So first we'll multiply 1 times 4, and that's just going to give us 4. Then we're going to multiply our like bases. So we have x squared and we have x cubed, and we're going to multiply those together. And our rule says when multiplying like bases, keep the base and add the exponents. 2 plus 3 is 5. We also have y. Sorry, let me start that over again. We also have y and y squared that we're going to multiply. So we need to keep the base and add the exponents. Well, there is no exponent on this y, so what exponent do we put there? We're going to put a 1 when there is no exponent. So y to the first times y squared will give us y to the third. 1 plus 2 is 3. All right, let's move on to another example. So as we did in example 2, we're going to start by multiplying our coefficients. 2/3 of 12. Well, 1/3 of 12 would be 4, so 2/3 of 12 must be 8. Now we're going to identify some other like bases. We have x squared and we have x cubed. We also have y and y cubed. And we have a lonely w. Nothing to multiply that w by, so he's just going to come out here. So now we're going to multiply our x's. X squared times x to the third will give us x to the fifth. Now we multiply our y's. Y y, come on green, y times y cubed. Remember, this is y to the first power because there's no exponent on it. We write a 1 there. Y to the first times y to the third will give us y to the fourth. All right, example 4. Again, we'll start by multiplying our coefficients. -5 times -3 is positive 15. Now we actually have 4 different bases. We have A, B, C, and D. So we'll have to multiply A squared and A to the -2. We will have to multiply B to the -3. And there's nothing to multiply that with, so actually I'm going to take my color off there and save that for another one. That B to the -3 is lonely. We'll have to multiply C to the fourth and C to the first. Remember, an exponent only applies to what it touches. This 4 only applies to the D. And we will also have to multiply D and D to the fourth. So that will be D to the first and D to the fourth. So let's multiply. Let's do our A's first. A squared times A to the -2. Well, 2 plus -2 gives us 0. So that's just going to be A to the 0. B is lonely. It doesn't have anything to be multiplied with, so we're just going to bring it out here. B to the -3. Now we'll do our C's. C to the fourth times C to the first will give us C to the fifth. Now we'll do our D's. D to the first times D to the fourth will give us D to the fifth. Now, do you see anything that can be simplified here using our rules that we learned in our last video? Well, I see a 0 exponent, so we know that A to the 0 is equal to 1. So this will become 15 times 1 times B to the -3, C to the fifth, D to the fifth. Anything else that can be simplified? 15 times 1 is 15. We also know that we don't want to leave anything with negative exponents. So this B to the third is going to need to scoot down to the bottom of the fraction. So we're going to take that B to the third and we're going to move it to the bottom of the fraction. So I'm going to do a fraction bar here and I'm going to put my B to the third on the bottom so I can change the exponent to positive. Then C to the fifth, D to the fifth. And now my expression is completely simplified. All right, let's go on to the power of a power rule. This says that we need to multiply exponents outside parentheses with each exponent inside parentheses. So it's kind of like distributing the exponent that's outside the parentheses to every exponent inside the parentheses. So let's talk about how this works. We have x to the fourth raised to the 5th power. So basically what this means is we are multiplying x to the 4th 5 different times. Well, according to the product rule, when we multiply like bases, we should add our exponents. So 4 plus 4 plus 4 plus 4 plus 4 equals 20. A shorter way of doing that is to take 4 and multiply it by 5 to get our new exponent. So when you see an exponential expression raised to a power, you are going to multiply the exponent outside the parentheses with every exponent inside the parentheses. Let's do example 2. As I said before, this is going to be like distributing the exponent outside to every exponent inside the parentheses. Let's first write in the exponents that aren't there. Negative 3 does not have an exponent, so we're going to raise it to the 1st power. Y does not have an exponent, so we're going to raise that to the 1st power. Now we're going to distribute the 7 exponent. So our rule says that we have to multiply that 7 by every exponent in the parentheses. So we'll have negative 3 to the 7th power. 7 times 1 is 7. Then we'll have x to the negative 14 power. 7 times negative 2 is negative 14. Then we'll have y to the 7 times 1 is 7th power. And we will have z to the 7 times 4 is 28th power. Now we need to ask ourselves if we can simplify in any way. Okay, first of all, negative 3 to the 7th power. Let me open up the calculator here. What is negative 3 raised to the 7th power? Can we do that on here? I don't think this calculator is going to help me. Okay, so if I use my handy dandy cell phone, I've got negative 3 get my scientific calculator on there. So I have negative 3, close parentheses, and I'm going to can't figure out how to raise it to the 7th power. Raise it, here we go, to the 7th power. And that's going to give us negative 2,187. So negative 3 to the 7th power gives us negative 2,187. X to the negative 14. How do we make a negative exponent positive? Well, this x to the negative 14, remember, is going to have to flip to the denominator. So let's put that x to the 14th in the denominator. We flip it to the denominator and the 14 becomes positive. All of the rest of our exponents are positive, so they can stay where they are. Y to the 7th and z to the 28th. Okay, let's do one more example, this one with a division problem. So the 2 is going to be distributed to each exponent in the parentheses. And distribute means multiply, so 2 times 5 is 10. So x will be to the 10th power. The y stays in the denominator where it is. 2 times 3 is 6. X to the 10th, y to the 6th. Okay, moving down to our last rule, which is the quotient of powers rule. So this is going to say when dividing like bases, we're going to keep the base. And what do you think we will do with the exponents this time? Dividing like bases, keep the base, and if you said subtract the exponents, you were correct. When dividing like bases, keep the base and subtract the exponents. Now the important thing here is going to be always to do the larger exponent minus the smaller and keep the base where the larger exponent is. So 5 minus 2 is 3. The larger exponent is on top, so we're going to keep our answer on the top of the fraction. So x cubed, we could say over 1, or we could just say x cubed. Okay, example 2. First of all, we're going to divide our coefficients by simplifying this fraction. We can think of this as split up into two fractions, 6 over 9 and w cubed over w to the 4th. And we're going to deal with each one separately. Well, if we divide 6 and 9 both by 3, this fraction reduces to 2/3. Now we need to do the division of the bases. Notice that our larger base is on the bottom, so our base is going to stay on the bottom. We're going to subtract the exponents. 4 minus 3 is 1. So our answer becomes 2 over 3w to the 1st power. Okay, in example 3, we have two different like bases that we have to divide. A squared divided by a cubed. And we also have b to the 8th divided by b to the 1st. So let's follow our quotient of powers rule. We're going to keep the base and subtract the exponents. So with the a's, the larger exponent is in the denominator. So the a is going to stay in the denominator. Subtract the exponents. 3 minus 2 is 1. When dividing the b's, the larger exponent is in the numerator. So the base is going to stay in the numerator. 8 minus 1 is 7. The answer is b to the 7th over a to the 1st. Okay, one last example. We're going to treat this example as 3 different fractions to simplify separately. First, we have negative 4 over 12. We also have x cubed over x squared. And we have y to the 1st over y to the 4th. So first, let's simplify our fraction. Negative 4 over 12. If we divide negative 4 and 12 by 4, we will get negative 1 over 3. Negative 4 divided by 4 is negative 1. 12 divided by 4 is 3. Now we'll divide the x's. Our larger exponent is in the top, so the x is going to stay in the top. 3 minus 2 is 1. Now we divide the y's. Our larger exponent is in the denominator, so the y stays in the denominator. 4 minus 1 is 3. We can simplify our answer just a little bit. We can say that this is negative x to the 1st over 3y cubed. And we'll do the My Turn problems in class.